Let's start filling in this table based on the information that we know. We know the probability of having cancer is 1%. So that would go right here in the margin. We know the probability of not having cancer is 99%. That would go right here. So boom, there those guys go. What else do we know? Well, we can figure these out, can't we? Because we know this is the probability of having cancer, and we know this is the probability of testing positive given that you have cancer. So that's this times this. Great, so 0.01 times 0.8 is 0.008, or 8 thousandths. That's really 0.8%. So what else do we know? We also have this marginal, and we have this conditional. That's right here, the probability of not having cancer times the probability of testing positive given that we do not have cancer. This times this, right? Let's put that in. Great. Now then, we know that this marginal right here means when we sum this joint with this joint, we have to get this value right here. So we can figure both of these out easily based on just this minus this gives us this one, and 0.99 minus this gives us this one. Great. We could have also found them out using these. Either way, both ways are legitimate. Now we can sum down the columns to find these other marginals. So this plus this will give us this one, this plus this will give us this one. Great, so we filled out the whole table. We didn't really need to do this, but it was a good exercise because these tables are extremely useful. Great, so just to kind of reduce the clutter, we can keep only the values. Now how do we find this? How do we find the probability of the probability of cancer given that the test result was positive? How do we find that? Well, the joint of positive and cancer over the marginal of positive, right? This right here, which is just this, which is just this. So this over this gives us 10.34%. So the probability of actually having cancer, given that you got a positive cancer test result, is only 10.34%, just over 10%. Shocking. There's another way to think about it if the tables aren't doing it for you, and that's using tree diagrams. So this is the way that I was actually introduced to Bayes' rule in a textbook a long time ago. And it started out like this. It said, okay, if you're right here, then these two things have to add up to 100, right? Having cancer and not having cancer. So 1% and 99% make 100%. But so given that you have cancer, there are two possible outcomes. You either test positive or test negative. So these are the conditionals. Given that you have cancer, the conditional probability of testing positive is 80%. Great. So these are familiar things, just represented differently. Likewise, given that you do not have cancer, the probability of testing positive is 7%, and the probability of testing negative is 93%. To find the joints, we just multiply. We multiply the probability that you have cancer times the probability that you test positive given that you have cancer, and that gives us 0.008, or 0.8%, like we saw in the previous slide. Doing this for all of these just fills in those joints, just like in the table. Now, finding the probability that you have cancer given that you test positive based on this information is now pretty easy, right? Because this is our joint, testing positive and having cancer, over what? Over the probability that you test positive, right? The marginal. That's this one plus this one. This one tests positive, and this one tests positive. So out of all the ones that test positive, we're only interested in the fraction of those that also have cancer. So writing it out, this over these two summed up gives us 10.34%, just like we saw in the previous slide. So either way, either method works, whichever one you feel more comfortable with. Both are really useful to know, though. I'm going to leave you with a question. So the probability that a person is male given that the person smokes cigars. Let's say that 49% of adults in a certain population are male. And further, let's say that, given that a person is male, 9.7% smoke cigars. Also, let's say we know that 1.7% of women smoke cigars. If we randomly smell cigar smoke, what is the probability that a male was the person smoking a cigar? Think about this for a second.